Hello. One of the questions that's come up a lot when people use the part-9 bracing calculator is to try and understand how to take inputs from a building plan design and accurately input them into the calculator. It's a really important part in the process, and I apologize. I've made it a little bit confusing in the past by sort of changing my mind on a few different things. But I wanted to record this video just as a really brief and hopefully easy to understand example on the sort of inputs that the calculator is looking for and how to derive them from your set of plans. This is particularly intended for designers, but I suppose anyone else who's interested in using the calculator. So just imagine what you got in front of you here is a really simple plan of a Part 9 building, looking from above, obviously. And then up in the top left-hand side there, we've got basically a simple list of processes that need to take place to help us derive the information that is required to enter into the Part 9 bracing calculator. And so the first thing that we have there is that we need to find the building plan extents. And so I've spoken about this in a number of videos in the past, but basically we're trying to figure out how our building footprint on each story can fit into an extending rectangle. And so in this case, it's pretty clear. Basically, there's going to be an extending rectangle that is going to sort of encompass this plan. So I'm going to start off by drawing that in blue. Hopefully easy to do through the camera here. So the extending rectangle going to be something like this. And so that would just be indicative to find the building plan extents. Now from here, our next part is that we need to label the axes. And so to do that, it doesn't really matter just as long as it's consistent. But typically we would see a set of building plans sort of oriented like this with a long side and a short side. And so typically I'd be labeling these ones as the horizontal axis. Okay, so that would be this dimension or this line, this axis. And then the vertical axis would be this one. Something like that. So that would be labeling the axes. And so this would be a horizontal axis, and so this would be a horizontal axis, and then this is vertical, and then this is vertical. Okay. So the next thing we need to do is we need to find the building plan dimensions. Now, to do this, basically we're trying to understand how those horizontal and vertical axes intersect. So in this case, it's pretty clear. So our building plan dimensions along the horizontal axes are going to be from this point to this point. And so let's, for example, call this 40 meters, and that is the building plan dimension along the horizontal axes. Next, we need to consider the vertical axes. So the same sort of process applies. Where do the extending rectangle plan extents intersect? And so we have over here and here. And that, hypothetically, let's just call that one, let's call it 15 meters. Well, let's call it 25 meters. And that is all right, so that's going to be 25 meters along the vertical axes. All right, so there we have, we found our building plan dimensions. And again, This is the horizontal axis, and so this is 40 meters of building plan dimension along the horizontal axis. And this is our vertical axis, and this is going to be 25 meters of building plan dimension along the vertical axis. And so next on the list, we need to ID the bands. Now, I haven't indicated any brace wall bands on this plan yet, so I'm going to start off with that. Now, all the horizontal bands, I'm going to do them in pink. Again, this is just hypothetical. And so let's consider that to be our horizontal bands. And then our vertical bands, we're going to do them in green. So let's consider the green highlighter there to be our bands running vertically. Now, so the process that we're on at the moment is to ID the bands. And so to do that, obviously, we need to know where the bands are, and then we need to start labeling them. And so this is important for the calculator to make this distinction. The process is set up in the calculator so that all the bands that are identified along the horizontal axis, so in that case, that's going to be all our green bands that are running vertically. So they're along the horizontal axis. These are labeled in the calculator numerically. So that's your 1, 2, 3s, and all the way up to 10. And similarly, all the bands that are going to be labeled along the vertical axis here, so the bands running horizontally, they are going to be labeled A, B, C, D, all the way up to J. So I'm going to go ahead and do that now. Let's start with the bands along the horizontal axis. So this is going to be, I'm going to call this band 1. This one here, I'm going to be calling it band 2. And this is band 3. Okay, and then for the bands along the vertical axis, let's call this one A, this one B, and this one C. All right, so that's how I'm identifying the bands. Now, it's really important to make this distinction because it is sort of intrinsic to the way that the calculations work in the calculator that this building plan dimension, the horizontal axes, the building plan dimension along the horizontal axes, is going to be related in the same way to these bands and these bands. So these are essentially the whole layout has to match for the calculations to work. And the reason for that is because when we're considering, well, for a lot of different reasons, but primarily when we're considering forces on a building due to earthquake, we need to consider the length of a building that is parallel to a band, and particularly when we're considering the amount of bracing in that band, we need to understand the building plan dimension parallel to that band. And so this relationship is important. This is the way I have it set up in the calculator. I recognize that there are probably different other ways to do it. But if you follow this procedure and start off by labeling your horizontal axes and your vertical axes, measuring your horizontal building plan dimension and your vertical building plan dimension, and then labeling your bands similarly with the numerical numbers along the horizontal axes, and then your alphabet along the vertical axes, you're going to be entering information that is appropriate for the calculator to understand. Okay, so that was our fourth task, which was to to ID the bands. And then finally, we need to find the band spacing. And to do that, it's a pretty simple procedure. So to find the band spacing, first off, what we need to do is find the distance between the center line of the furthest end bands in each orthogonal direction. And so Along the horizontal axes here, the furthest end bands are 1 and 3. So hypothetically, we would find the center line of those bands, and then we would measure between them. All right, so that would be that distance there between the center lines of the furthest end bands. And when we knew that dimension, we could input that into the calculator. We also tell the calculator that in this orthogonal direction, there are 3 bands. And so the calculator is going to determine the average band spacing for these 3 bands. The same thing works up the vertical axes when we're considering these bands. Again, we're finding the center line of the furthest end bands. So that's the end bands in this case are A and C. We're going to measure between them, and we're going to enter that measurement into the calculator when trying to understand the band spacing for bands along the vertical axes. So just recapping, we have 5 steps to do when we have our building plan. We need to find the building plan extent. So that's that idea of the extending rectangle. Next, we're going to label the axes. So that's going to be our horizontal axes and our vertical axes, all right, on that extending rectangle. Third, we're going to find the building plan dimensions by understanding where those axes intersect, all right? So then that's going to pull out our horizontal building plan dimension and our vertical building plan dimension. After that, we are going to ID the bands that are going to be on your design. So I illustrated that here in the pink and the green. So the bands that run vertically, they run vertically, but they are identified along the horizontal axes. They need to be labeled 1, 2, 3, 4, etc., all the way up to 10. And then for the bands that run horizontally, but along the vertical axes, identified along the vertical axes, they're going to be labeled A, B, C, etc. Finally, the last step is that we need to find the band spacing. And to do that, we just need to understand where our furthest end bands are. And then we need to measure between the center line of the furthest end bands. And then when we input that number into the calculator and tell the calculator how many bands we have in that orthogonal direction, it will determine the average band spacing in that orthogonal direction. Now, hopefully that's been helpful. I'll be posting this. Please share your feedback, and I'll be posting this as a little picture as well. So hopefully it'll be helpful as people open up the tool. Thanks.